calm before the storm. Things aren't as they were before. Your best
Hello there.
Did you think you could keep us out? Shut the gates, forget us now. Tides are changing. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. We're the We're the ground beneath your feet. We're the whisper in the tree. Do you feel us watching? Hunger in our eyes, victories on our minds. It's our time to rise. Can you hear the sound? Can't stop us now. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution. We're not back in town, know what we're doing. Things are about to change, it's evolution. Voices shake the ground, you feel it moving. We're the revolution.
Drop it like that. Drop it like that. Drop it like that. Yeah, we drop it like that. Yeah, we drop it like that. Drop it like that.
Good evening, everybody. It's Obi-Wan Pez for N-Simplex Pachinko. We are going to be looking at some Transcendental numbers by Solomon Marcus. This was brought to my attention via one of the other things that we were doing last week, I think. Right, because I was led on to somebody else. Who was it? Well, anyway, while I look that up. No. No. Anyway, I think I was watching some YouTube video and it linked me to somebody in particular who then linked me to Solomon Marcus. And I was like, this ought to be interesting. No, there's no... It's not on my search. Oh, Federico Adia. He was on a podcast a long time ago with Steve Strogatz. I think it was 2016, 2018, something like that. Maybe in 2021. I don't know. And he had mentioned Solomon Marcus, and I thought it would be a good idea to look up some of his stuff. And then this actually looked like reasonable, that I might be able to actually understand it. So, at the very least, let's try it. So, hope you all are having a lovely evening so far. So, Famished and Megalomorph, good evening. Welcome back. Right, we good? I think we're good. Okay, also, up in the top, you can't see that arm. Up in this top stuff, way up at the top, we have GOtEL, which is Game On to End Lupus. It's true, I'm not gaming tonight, and also the link all the way at the bottom there, the QR code. That is linking to... I probably need to hit the go button on that, actually, now that I'm thinking about it. If anyone is in such a position that they would like to donate to GOtEL, it would be really awesome. We are working with 8BitD and Coco Confession and a bunch of other people. I think Elbel is also doing it. There's a bunch of people. And they are... Yes, this is a draft. Publish. There we go. So, I have posted the $250 goal, same as last year. There is a bit of incentive on it if anyone wants to mess with me. There are going to be incremental goals as well as overall goals. I did not restart my computer. Curses. So we have... cool. If we make it up to $50, I will do a math topic instructional stream on that particular topic specifically. I will do some extra research, all that good stuff. If we make it to 100, I will do a speedrun stream of your choice. We'll do a poll. If we make it to 150, I will do another math stream on a voted topic. Yeah. The fact that we have two, right? It was originally like a karate stream, but again, we don't really have space for that, so that's how I get out of it, right? In theory, I could do this in my yard or something, but nonetheless. and $200. If we make it all the way to 200, we'll do a community game with viewers, and those who are playing get to decide what we're going to do. In addition, if we individually give $15, I will do some sort of extra workout, drop and give me 20, do another karate tai chi sort of thing, etc. The hot stuff is our typical they are bol peppers, which are currently sitting in rice so that they stay dry. For $40, you may purchase a math topic of your choice, and I will do some research and try and look stuff up. Now, keep in mind, if this is something that's beyond me, i.e., like, most of the stuff that I read on this stream, I may have to refuse. It needs to be something that I can actually grasp. And then for $75, we will go with the much hotter picino peppers. So these are little teeny ones, and I'll eat probably 2 of them at a time if anybody goes for 75. And yes, this was probably a mistake. I need to make those active, don't I? There we go. That might actually work. And then again, milestones. That didn't change anything here. Okay, cool. On the ribbon. So. Anyway, if anyone is interested in that, go for it. Thank you so much to anyone who does donate. The GOtEL campaign as a whole is all about ending lupus. Lupus is a immunological disease about which not a whole lot is known, unfortunately, and people are trying to raise money and awareness to try and get greater awareness, better research going on it, because typically there isn't a whole lot of research done on lupus, and unfortunately the recent administration decided that they were going to cut funding for basically everything quite a lot. So lupus also did, the lupus foundations did suffer a bit of a hit because people aren't getting the help, medicine, and research that they need in order to get better. So, on that terrible note, going to look at Solomon Marcus's December 5th, 2017 edition on this is the archive link to it. I don't remember where I actually saw the original link because it wasn't here, or it wasn't on archive. You have to because it's so far back in the past, you have to have the link to it, or be able to search for like his name. Right, so on Transcendental numbers, new results, and a little history. Solomon Marcus, Institute of Mathematics, Romanian Academy, and Florin Nikita, Emar.Romania. Yeah, okay, so it's the same Institute of Mathematics at Romanian Academy, of the Romanian Academy. And here we have again published 5th December 2017. Abstract, attempting to create a general framework for studying new results on transcendental numbers. This paper begins with a survey on transcendental numbers and transcendentants, and then presents several properties of transcendental numbers E and pi. It then gives proofs of new inequalities and identities for transcendental numbers. Also, in relationship with these topics, while we study some implications for the theory of Young-Baxter equations, we propose some open problems. One of the most famous formulas in mathematics, the Euler equation, e to the pi I plus 1 equals 0. Sorry, Zach. Contains the transcendental numbers e, pi, the imaginary number I, the constants 0 and 1, and transcendental operations. Beautiful, powering, and surprising, it has changed mathematics forever. We will unveil profound aspects related to it and propose the counterpart, e to the I minus pi, absolute value, is less than e. An interpretation of this inequality may be seen here, which has a interesting geometrical interpretation. So b hat is approximately 1 radian. In some sense, formulas 1 and 2 can be unified, and we'll explain in section 3. The next section of the current paper is a survey on transcendental numbers, transcendental functions, transcendental operations, and transcendentants, following the ideas from 1 and 2. Section 3 deals with identities and inequalities of transcendental numbers. In section 4, we start with some comments. We propose some open problems and prove our new results. Section 5 contains results related to Young-Baxter equation. In the last section, we draw the final conclusions. Transcendentants and transcendental numbers in mathematics. The term transcendentants has been introduced to express issues related to the divinity, implying initially the aforementioned attributes. It produces an inflation of uses nowadays. Movies, novels, jazz albums, corporations, game brands, poems, internet websites, blogs, names of all kinds of doctrines, philosophies, etc. The trans prefix comes from Latin implying passing through a certain area, and it is all around: translation, transport, transmission, transformation, transplant, transparent, transgress, transdisciplinary, etc. One talked for the first time about transcendentants in mathematics in the 18th century, and it was Leonhard Euler who initiated this discussion. Leibniz was the first referring to transcendentants in mathematics. Euler does not refer directly to transcendental numbers, as it happened subsequently in the 19th century, but he refers to transcendental operations. The non-transcendental operations are addition, subtraction, multiplication, division, exponentiation, and rooting, which is also exponentiation. And in comes a raid! Hey Zach, how's it doing? How's it going? Hope you all are having a good night. Thank you so much for the follow. Woohoo! 770 followers. Awesome. Glad to see everybody. My name is Obi-Wan Pez, for those of you who don't know. We are here at NSimplex Pachinko doing, well, tonight is Math Communication Monday, and we're looking at a paper on transcendental numbers by Solomon Marcus, who was linked inside of a paper by Federico Adia, and I believe he was also the subject of part of the conversation that Federico had with Stephen Strogatz in his The Joy of X podcast, which came out a long time ago. I only just recently listened to that particular that particular podcast, so it's quite interesting. Zach, I hope 16 worked out nicely tonight. Played nicely. Hopefully it wasn't driving you too mad. Going well? Yeah, nice. May 29th. It is coming. Time does that for some reason. We're all a little mad here. Absolutely. 100%. Not to say we all float down here. All right, so where are we? Right. Yeah, so rooting is also another form of exponentiation. So we do technically argue that, yeah, okay, we're talking about like rational exponents when we include exponentiation asterisk of integers. Then we could say like, oh, but now we can include rooting to include the integer roots of numbers. I guess. Yeah, applied to integers and those numbers that are obtained from them by such operations. So, why are all these operations considered non-transcendental? They're considered to be algebraic operations because all numbers generated in this way are roots of some algebraic equations. We refer to these equations expressed by polynomial structures where all mentioned operations are applied for a finite number of times. Focus on finite. And as soon as this is not the case, we enter the field of transcendentals. So here we're talking specifically about those things that are the solutions to all possible polynomials which have similarly rational coefficients. And I suppose we might also then start including any of the algebraic numbers that we create through this method as possibly being coefficients as well. I don't know. What do you think, Zach? Call you out. If we include all algebraic numbers as we find them, as we find the families of them, as the coefficients of polynomials. Right, that's never going to end up with our transcendental numbers. We're always going to end up with further algebraic numbers as solutions to those equations. Okay. I think. All right. Therefore, we are suddenly suggested that in mathematics, the idea of transcendence is essentially related to the idea of infinity, not just any kind of infinity. For Euler, the entry in mathematical transcendence is in the differential and integral calculus. Why is Euler considering exponentiation a to x, the logarithm, trigonometric sinus cosine functions, as being all transcendental functions and operations? Because they're immediately associated one way or another to the mathematical idea of integral. They are immediately associated to expressions which include an integral. For instance, the logarithm associated to the integral of dx over x. For Euler, the function log x plus 7 is transcendental, but log 7 plus x is algebraic. I mean, like, I understand it. Also, I might have some trouble explaining it to somebody who doesn't know. The passing from non-transcendental to transcendental is gradual. Such an assertion deviates us from mathematical rigor, but it consolidates our understanding. We have in mathematics the situation of irrational numbers, where the word irrational would suggest transcendentance, but is immediately completed by the word algebraic in the negation of transcendentant, such as the square root of 2. We may consider the algebraic irrationals as a passing bridge, therefore intermediary when passing from non-transcendental to transcendentant. Can I borrow $40 to donate $40 to you? Yeah, unfortunately famished. Oh, and I do have my I do have my company set up over here in the UK, so I am trading under N-Simplex Productions. So now all of the many dollars that come in through Twitch streaming, lol, end up going to the, my, it's not really corporate, but my entity, which is a sole trader here in the UK. I think when I get back to the US and I file for same thing, like it's not a, I think I can file for the same thing and it's super easy. Yeah, and basically, as long as I don't become a humongous streamer, they're just going to laugh at me when tax season comes and be like, yeah, no. Don't even file the paperwork. It's not worth it. Oh. We have in mathematics a situation of irrational numbers, where the word irrational would suggest transcendentance, but it is immediately completed by the word algebraic, the negation of transcendent, such as the square root of 2. We may consider the algebraic irrationals as a passing bridge, therefore intermediary when passing from non-transcendentant to transcendentant. It is not rigorous, but it is suggestive. We must add another thing. We talk about rational numbers, such as 2/3 or -3/7, and irrational numbers. We are tempted to associate such irrational numbers as the square root of 2 with something beyond reason, hence the word irrational. But the Latin etymology clarifies the fact that rational is sending here to ratio as fraction. So in modern understanding, as a number of the form a over b, where a and b are integers, b is not 0. And irrational just rather means not a nice ratio. Joseph Louisville is the first to manage to encounter an example of transcendental numbers. This important discovery happened in the year 1844. Louisville introduced a class of real numbers wearing subsequently his name. The real number x is a Louisville number if there exists an integer b higher or equal to 2 and an infinite sequence of integers a1, a2, etc., an, etc., so that x is the sum of the series, having general term the ratio between a sub k and the power of exponent k factorial of b. For b is 10, a sub k equals 1. For any k, x becomes Louisville's constant. Okay, so a sub k equals 1 for any k, and b is 10, which will have an exponent of k factorial. They're mixing k's and n's, and I don't like that. I think that should be a sub k in here. Comment. Could you imagine if they somehow allowed me to comment? Me to comment. Concerning his numbers, Liouville proves that they are not algebraic, they are transcendental. It was the first example of non-algebraic real numbers. Another presentation of Liouville's numbers stands on the manner of approximation by rational numbers. X is a Liouville number if, for any natural number n, there exist integers p and q, with q higher or equal to 2, such that the absolute value of the difference between x and p over q is strictly between 0 and the fraction having 1 in the numerator and the value of q to the nth power as the denominator. It is thus clear that Liouville numbers have the privilege of a tight approximation by rational numbers. Right, so we're never going to be able to find these particular rational values that match these transcendental numbers, not just irrational. This fact is against our intuitive expectations because it shows that in some respects, transcendental numbers are nearer to rational numbers than algebraic irrationals. Right. So that's my... that was why I made a face. I mean, even that. So Megalomorph, Famish was specifically talking about the GOtEL thing, I think. But... so that's not even, that's a charity, that's not me. Yeah. Because $40 gets you to purchase a math topic of your choice, provided that I know how to teach it. Or feel comfortable in researching it and being able to teach it. If you're like, yeah, do some topology, it's probably not going to happen. But hey, we could work. All right. The manner in how rational numbers are diligently running to get close to the transcendental numbers urges us to see the transcendentance process in exactly the infinite range of approximations of transcendental numbers. This situation suggests us to generally regard transcendentance as a result of an asymptotic process when all stages are in the terrestrial universe, but the infinity of the number of stages makes it impossible to be crossed in real time. Such a view increases the rightfulness of the hypothesis of absence of a sharp border between transcendental and terrestrial. The relation between Liouville numbers and other important classes of real numbers has been studied recently. Number 5. It is noticed that Liouville numbers are encountered in a remarkable class of numbers, but are encountered in a remarkable class are encountered in remarkable classes of real numbers, but as rare exceptional phenomena. Okay. There are other philosophical enigmas related to mathematical transcendence. One would expect that transcendental numbers such as pi and e are somehow farther from rational numbers than irrational or algebraic numbers. But in terms of approximation by rational numbers, it seems that this does not happen. It must be noticed as well that transcendental numbers are more than algebraic numbers, but more here means a metaphoric extension of such a qualification from finite to infinite. The mathematicians are expressing this by the following statement. Algebraic numbers form a countable set, while the transcendental numbers form an uncountable set. It is a set of the power of the continuum. How do the algebraic numbers form a countable set? You had a class. Student is now 11 minutes late. Oh no. Is it a class of one? Or is it like just that only one usually shows up? Class of one. Nice. Only countably many polynomials with integer coefficients. Okay. I suppose they could, in theory, be extended in an extra dimension to include rational coefficients. We're just basically doing the Cantor thing, but now like spiraling out essentially to get all of the possible rational coefficients in all of the places. Clear denominators. Yeah, okay. No, that's fair. Of course you can. That's they're literally equivalent. Okay. Finite product of countable sets is countable. Countable union of countable sets is countable. Okay. And again, I guess I would have also assumed that algebraic numbers I think intuitively algebraic numbers are also of the uncountable variety, but I guess not. If you're unsure on either, it's an exercise worth doing. So I get the finite product and countable union. That's okay. Guess the only question I would have is, are algebraic numbers truly also part of the countable set? I don't think I've ever actually done that one. for each polynomial, degree n there, and roots, since there are only countably many such polynomials. Okay, so again, it's see previous statement. Yeah. Man. Yeah, okay, cool. Thank you. Again, it seems to defy the common sense, but you know, common sense isn't. And our sense is really not worth much in terms of you know, mathematical understanding. You have to really delve into it. All right. Following identities which contain transcendental numbers e and pi are well known. Infinite integral of e to the negative x squared dx is going to be equal to root pi. I definitely remember doing that one in complex analysis. Intuition is built on finite things. Yeah. Yep. Infinite. Yep. The all real integral of e to the negative I x squared dx is equal to pi over 2 times the quantity I minus 1. These formulas, unified in the paper 6, can be proved by contour integration. Yes. Right, so complex analysis, for anybody who hasn't already taken complex analysis themselves. Wonderful, brilliant class. Allows you to show that, like, you can map a particular integral set of numbers, set of yeah, set of anything really, into complex space, and then as long as you perform the same reverse mapping after doing it, the integration becomes super simple. Integral 4 bothers you. The norm of the integrand is always 1, so it's not an L1. Other inequalities for e and pi are quite new. For example, absolute value e to the 1 minus z plus e to the z conjugate is greater than pi for all z in complex. The integral from a to b of e to the negative x squared dx is less than or equal to e to the e over pi times the quantity 1 over e to the pi a minus 1 over e to the pi b. With an extended Riemann integral, you can always make it work, taking the limits, but measure theory makes me wary of things like that. Okay, it's fair. You probably want to see how they did it. Still, other relations will be proved in this paper. 2 and the experimental informal formula 6. Absolute value pi to the I minus I to the pi is equal to 2 sine of pi squared on 4 minus natural log of root pi. Let us consider two variable complex function f. Complex cross complex going to reals. F of zw is equal to absolute value e to the z plus e to the w. The formulas 1, 2, and 5 can be unified using the function f, where f at pi I, comma 0 equals 0. F of 1 minus z, z conjugate is greater than pi for all z in complex. And f of I, pi I plus natural log of pi is less than e. Further comments. There exist real solutions for the equations x squared minus pi x plus 1 over r to the r equals 0. Okay. Where r is in rationals asterisk. I'm not sure what the asterisk is. I have not done that in 20 years at least. For r sufficiently small, but there are no real solutions for the limit equation when r is infinitely large. X squared minus pi x plus e equals 0. Because delta equals pi squared minus 4e is less than 0. The question if delta is equal to pi squared minus 4e is a transcendental number is an open problem. Resembling the problem of squaring the circle, the geometrical interpretation of the formula pi squared less than 4e could be stated as the length of the circle with diameter pi is almost equal and less to the perimeter of a square with edges of length e. In this case, the area of the above circle is greater than the area of the above square because pi cubed is greater than 4e squared. Length of the circle with diameter pi. Oh, pi d, right, yes, of course. But then if we do length of the circle with diameter pi is almost equal and less than the perimeter of a square with edges length e, right? That's fine. I understand that. In this case, the area of the above circle, so that'd be pi times r squared, which would be half pi all squared. So we get a quarter, 1/4 pi cubed would be the left-hand side. Then the area of the above square, right. The area of the above square is e squared. So then we transfer the 4. Okay, jeez. Circle with diameter pi, square with edges length e have almost the same perimeter. Okay. For an arbitrary closed curve, we consider the smallest diameter d and maximum diameter big D. These can be found by considering the center of mass of a body which corresponds to the domain inside the given curve. 1. If L is the length of the given curve and the domain inside the given curve is a convex set, then we conjecture that L over D is less than or equal to, okay, this is the length of the given curve divided by maximum diameter is less than pi, is less than or equal to the length of the given curve divided by smallest diameter. Okay. Makes sense. 2. Moreover, the first inequality becomes equality if and only if the second inequality becomes equality if and only if the given curve is a circle, right? Since these are bounds, we have a lower bound and an upper bound for the ratio between the diameter and the total length of the curve. Consider the center of mass of body, which corresponds to the domain inside a given curve. Okay. Yeah. Non-zero rationals. Three, if the area of the domain inside the given curve is A, then little d big D is greater than A. The equation x squared minus L over 2x plus A is equal to 0 is not completely solved. For example, if the given curve is an ellipse, solving this equation is an unsolved problem. Solving the equation x squared plus the infinite sum of 10 to the negative k factorial x plus infinite sum from 1 to infinity of 10 to the negative k factorial equals 0, in which two coefficients are Liouville numbers. By using the quadratic formula is hard, yeah. However, one can use the formula ax squared plus a plus c x plus c equals ax plus c times x plus 1 in order to solve this equation. Solution x equals -1 can be observed directly. Okay. Following informal proof for identity 6 is related to the computers working over the complex numbers. So pi to the I minus I to the pi, we put in exponential form using e as our base. So e to the I natural log pi minus e to the pi natural log I is equal to e to the I natural log pi minus e to the I pi over 2. Okay, natural log I is I pi over 2. Okay. Is equal to the square root of... Why are you off? Come now, music. Oh. You decided that you were just done? Okay, cool. Square root of 2 minus 2 cosine of natural log pi times cosine pi squared on 2 plus, because we're using the cosine sum formula, plus sine of natural log pi times sine of pi squared on 2 is equal to 2 square root of 2 minus 2 cosine of natural log pi minus pi squared on 2, right? So now we combine the two pieces. It's 4 sine squared, because now we're calculating all of the okay, that's the half angle formula. Yep. Which is then going to be equal to 2 sine of all that stuff. So pi squared on 4 minus natural log of square root of pi, which is approximately 0.95. In connection with Formula 6, one could consider the equation x to the I minus I to the x, which is equivalent to e to the pi over 2 equals x to the 1 over x, which has no real solution because pi over 2 is greater than 1 over e. Right, strictly greater cannot possibly be equal. Right, proof for the inequality follows a similar fashion using Taylor series for cosine in order to approximate cosine of 1, and 3-digit approximations for e and pi. Transcendental numbers in mathematical physics. In some special issues on Hopf algebras, quantum groups, and Yang-Baxter equations, several papers, as well as the feature paper, covered many topics related to Yang-Baxter equation, ranging from mathematical physics to Hopf algebras, from Azumaya monads to quantum computing. Terminology of this section is compatible with the above cited papers. V is a complex vector space. I sub j is defined such that V... Oh dear. Right, complex vector space. Ugh. For all j in 1 and 2 are identity maps. I is an identity map. That's fine. Yes. Does anybody else giggle at the abbreviation of the Proceedings of National Academy of Sciences? PNAS. Yeah. Nice. I mean, like, if they didn't want to get made fun of. We consider J a linear map which satisfies... Okay, is that open circle the same composition as just like with functions? Because they're not discussing it. Function composition. Okay, cool. J is the function which maps V. I don't know what the circle of the X is. If we were writing with matrices, it would make matrix multiplication. Okay, yep. And J also follows or satisfies tensor product. Yay! Linear map which satisfies J times J is negative I2, and J12 times J23 is equal to... Okay, so that's, again... Suddenly you're feeling tensor. Yeah. It's not like too bad for me, but at the same time, like I certainly didn't finish that tensor book. Right, so J, okay, so J composed with itself is just going to get a negative of the identity. And then J12 with J23 is the same as, this is commutative, J23 with J12, where J12 is J tensor product with I1, J23 is I1 tensor product with J. Then R of x is cosine of x times identity 2 plus sine x j satisfies the Yang-Baxter equation. R12 of x times R23 of x plus y times R12 of y is equal to R23 of y times R12 of x plus y times R23 of x. Interesting. Okay, that's weird. Okay, so these are x, y, and z being tensor product id together, but associating the specific ones that are listed first. Proof 7 could be done by writing R of x equals e to the x j and checking that 7 reduces to x j12 plus x plus y j23 plus y j12 is equal to y times j23 plus x plus y j12 plus x j23. Such an operator J could have in dimension 2 the following matrix form 0, 0, 0, 1 over alpha I, 0, 0, I, 0, 0, I, 0, 0, alpha I, 0, 0, 0. Based on results from previous section, counterpart for the formula e to the j, e to the pi j plus I4 equals, 0 matrix 4. That's, yeah, of size 4. So in this particular case, it's a 0 vector of size 4. I4 is going to be the identity matrix of size 4. Yeah, so 1, 1, 1, 1 down the main diagonal. Reversing for your all's benefit here. J, I4, 0, 4 are all within the fourth, is that metric space in complex numbers? Could be the following identity, x squared plus e I2 is greater than pi x. For all x in metric space 2, for real numbers, asterisk plus. Trace of x is greater than pi. Replacing the above condition, 4x4 complex matrices. Okay, so not metric space. Okay, ads are going to start in 20 seconds, so we're going to hop downstairs and nope, that's got plenty in it. Grab a snack or something, stretch, definitely walk around a little bit. So be right back. Thank you everybody for coming, and GOtEL, right? Game on to end lupus. We've got the donation information up top and the QR code down below. So thank you very much. If anybody does end up donating, we'll see you all in 3 minutes. Hey there, welcome back. Let's see. Right, das thou ihn hoist. So we have our 20-pound weights, which we just do some arm curls, lift some shoulders, and then pull up and around the back. Keep the arms going. You know, the legs get a lot of workout, so we don't do much with the arms. Got to keep that up. Hope everybody's having a good night. Again, link at the bottom of the QR code there is for GOtEL, Game On to End Lupus. Lupus is an autoimmune disease which affects a whole lot of people. And again, the fairly recently asterisk, and by that I mean like in the last year and a half, a whole lot of United States federal funding as well as research has been cut. And so the Lupus Foundation would like some extra help, especially this year with all of the changes that are happening. The money goes toward research as well as direct help to benefit people who are living with lupus, so that they might get some medicine, better diagnoses, and hopefully some research projects going. But again, since much of that is tied to federal funding, we're having some problems. So write to your congresspeople, write to anybody who will listen, give them phone calls, bother them enough that they can't not listen to you. I believe they are legally required to at least take your phone call. You know, asterisk, provided you're a constituent. That's nice. Get some nice little popping in the sternum there. And a little bit later, I'm sure I will redeem again some Tai Chi warm-ups or something like that. These are nice, easy ones that you can do in the home, pretty much no matter where you are. All right. Later on, I do also want to get back into Elite Dangerous, because I need to catch my ride out of the Shrogo region of the galaxy, which currently we're about 200 to 300 light years away from the ship. Our jump carrier jumped away, so I no longer have a local rendezvous point. However, there are two other jump carriers that are in the immediate vicinity, and once I'm done with the scientific survey, which is going to take 1.5 more passes through some parts of the galaxy. So we're on these voxels, which are basically like big square prisms. And basically we start at 0 and then go up to 1,000. And then I translated, started at 1,000, went down, came back, or actually went to negative 1,000, translated, back up to 0. You know, that's kind of how I'm trying to make it work. Currently, what do we do? We went down first. So I started at 0, went to negative 1,000, translated, went from negative 1,000 to 0. From 0, we're about to here, right around 4 to 500, going up to positive 1,000. We need to translate and then go back down again. As our ship, or the jump carrier, is somewhere around 0 to 200, you know, somewhere in that neighborhood. We're also using the Caspian Explorer at the moment. Mine, of course, is named the Dawn Treader. I can't imagine how anybody would come up with that one. Laz! Yeah, it's been a while. How are you? We moved, about a month ago. And yeah, thank you very much for the follow, Aleph. If anybody has any questions about math, feel free and ask them. I'm not particularly, I like doing the math communication stuff, but that's not the only thing we do here. And besides, if somebody wants to have an explanation on something that I actually understand, I'd love to help out. Breathing a little bit hard, but that was just because we just did a little bit of a workout there. So. Yep. People in my house are breathing a little bit more ragged because of the pollen. England has finally bloomed most of the way through. Welcome to 54 degrees north. In fact, in our house, our new house, we just crossed the 54-degree north latitude line to get to our new place. We were just under it before, and now we're just above it. So, kind of cool. Season for cetirizine? Yeah. We do loratadine, but yeah. It mostly works. I am slightly concerned that fexofenadine might have screwed up my liver, so yay. We'll see about that. For example, in dimension 2, matrix operator. Okay. So, okay, try again. Based on the results of the previous section, counterpart for formula e to the pi j plus I4 equals 0, 4. All these belong to the 4x4 complex matrices. Could be the following inequality. X squared plus e times I2 is greater than x pi times x for all x in 2x2 real matrices, real positive matrices. Trace of x is greater than pi. Replacing the above condition, J12 times J23 equals J23 times J12 with J12 times J23 equals negative J23 times J12. The authors of 19 obtained interesting results. New realization of doubling degeneracy based on emergent Majorana operator. new solutions for the Yang-Baxter equation, etc. For example, in dimension 2, the matrix form of this new operator J would be 0, 0, 0, 1, 0, 0, 1, 0, 0, negative 1, 0, 0, negative 1, 0, 0, 0. With this case, we enter into the world of quaternions and Clifford algebras. Okay, so that is kind of interesting because now, instead of having a having a sort of like rotation to it, it's essentially doing a flip. And it's rotating through the coordinates somewhat. Reminds me of the binary solo from The Humans Are Dead by Flight of the Conchords. I don't think I'm familiar enough with it, unfortunately. I think my dad watched Flight of the Conchords obsessively, and I never got into it. Or he never... It was maybe never... Yeah, thank you. Copy link. Oh god, I've got so many YouTube videos on standby. Okay. For Boolean algebra, map RAB equals A mapped to B A is a solution for the constant Yang-Baxter equation. Same R's that we saw above. Proof is direct. Thank you. That's Author of 20 considers two types of scientists. Birds. They resemble scientists with a broad vision who try to unify theories, who obtain results of interest for a large readership, and frogs, which are less influential. Solomon Marcus used the terms of Francis Bacon, bees versus ants, while describing mathematicians who are involved in many different areas of research versus the mathematicians who worked in a restricted domain. Okay, bees going from topic to topic, ants working specifically on one thing. Because there is a huge number of new disciplines, it is important to have transdisciplinary understanding of the world. Transdisciplinary approach attempts to discover what is between disciplines, across disciplines, beyond all disciplines. Transcendence is a concept which plays an important role in theology, science, and art. It can be considered beyond all disciplines. Yang-Baxter equation appears across different disciplines. Mathematical physics is at the border of the two. The paper is written in a transdisciplinary fashion. We used results and concepts from algebra, mathematical analysis, mathematical physics, geometry, history of math, numerical analysis, epistemology, philosophy, etc., attempting to continue the approach of our recent papers and talks on the transcendental numbers. We brought together our investigations and presented new results. Freeman Dyson. Jeez. (2009) Died in 2020. Okay. Okay. Real quick, let's take a look and see what's new. Nothing this week. Network structure of mathlib. Inverse cube force law. History of 3 wrong definitions. Alright, we may have to just take a look at both of these and figure out what that's all about. Particle spiraling into the origin of an inverse cube force. Newton's Principia by, Inverse Cube Force Law by John C. Baez, published 26 April 2026. Newton's Principia is famous for its investigations of the inverse square law for gravity, but in this book, Newton also did something that remained little known until fairly recently. He figured out what kind of central force exerted upon a particle can rescale its angular velocity by a constant factor without affecting radial motion. Turns out to be a force obeying an inverse cube law. Given a particle in Euclidean space, the central force is a force that points toward or away from the origin and depends only on the particle's distance from the origin. If the particle's position at time t is r of t r of t belongs to reals of n dimension, and its mass is some number n greater than 0, then we have m times r double dot of t is equal to, right, this is force equals ma, so acceleration being our second derivative of its position r of t, times our mass is equal to force as a function of r of t and r hat of t, where r hat of t is a unit vector pointing outward from the origin at point r of t. Particle obeying this equation always moves in a plane throughout the origin, so we can see we can use polar coordinates and write the particle's position as r of t theta of t. With some calculation, we can show the particle's distance from the origin r of t obeys m times r double dot of t is equal to f as a function of r of t plus L squared over mr of t cubed. M r of t cubed. Here, L is equal to m r of t squared times theta dot of t. The particle's angular momentum is constant in time. The second term in equation 1 says that the particle's distance from the origin changes as if there were an additional force pushing it outward. This is a fictitious force, an artifact of working in polar coordinates. It is called the centrifugal force, and it obeys the inverse cube force law. This explains Newton's observation. Let's see why. Suppose that we have two particles moving in two different central forces, F1 and F2, each obeying a version of equation 1 with the same mass m and same radial motion r of t, but different angular momenta L1 and L2. Then we must have the following, and they must be equal to each other. So same mass, same position and motion, different angular momenta. Two different central forces. Okay, yeah, that's fine. School of Mathematics, University of Edinburgh. Nice. If the particle's angular velocities are proportional, then L2 equals KL1 for some constant k. So here we have this. F2 minus F1 is equal to k squared minus 1 times L squared 1, L1 squared, over m r of t cubed. Says that F2 equals F1 plus an additional inverse cube force. Particles' motion in inverse cube force has curious features. First, compare Newtonian gravity, which is an attractive inverse square force. Say F of r equals negative c over r squared, with c being greater than 0. In this case, we have m times r double dot of t equals negative c over r squared plus L squared over m r cubed. Because 1 over r cubed grows faster than 1 over r squared as r approaches 0, as long as the angular momentum is non-zero, the repulsion of the centrifugal force will beat the attraction of gravity for sufficiently small r, and the particle will not fall into the region. The same is true for any attractive force. F of r equals negative c over r to the p, with p less than 3. Huh. But an attractive inverse cube force can overcome the centrifugal force and make a particle fall into the origin. In fact, there are 3 qualitatively different possibilities for the motion of a weak particle in an attractive inverse cube force, depending on the value of c. With work, we can solve for 1 over r as a function of theta, which is easier than solving for r. There are 3 cases depending on the value of omega squared equals 1 minus cm on L squared, vaguely analogous to the elliptical, parabolic, and hyperbolic orbits of a particle in an inverse square force law. Makes sense? Okay. A cosine of omega theta plus b sine of omega theta if omega squared is greater than 0. A plus b theta if omega equals 0. Parabolic then. And hyperbolic, a e to the absolute value omega theta plus b e to the negative absolute value omega theta if omega squared is less than 0. Yeah, okay. The third case occurs when the attractive inverse cube force is strong enough to overcome the centrifugal force. The particle can then spiral into its doom, hitting the origin in a finite amount of time after infinitely many orbits. All 3 curves are called Coates spirals after Roger Coates' work on the inverse cube force law, published posthumously in 1722. Coates seems to have been the first to compute the derivative of the sine function. Interesting. After Coates' death at the age of 33, Newton supposedly said, "If he had lived, we would have known something." The subtlety of the inverse cube force law is greatly heightened when we study it using quantum rather than classical mechanics. Gitman, Tyutin, Voronov, self-adjoint extensions and spectral analysis in Calogero problem 2010. Oh, there's this one if anybody wants to take a look at the other bits that are in there. No, Chandrasekhar. Newton's Principia for the common reader. Subtlety of the inverse cube force law is greatly heightened when we study it using quantum rather than classical mechanics. Here, if C is too large, the theory is ill-defined because there is no reasonable choice for self-adjoint Hamiltonian. If C is smaller, the theory is well-behaved, but at a certain borderline point, it exhibits a remarkable property: spontaneous breaking of scaling symmetry. I hope to discuss this in my next column. The History of Three Wrong Definitions. Harold P. Boas, Department of Mathematics, Texas A&M. Published 27 April 26. Topic is the history of the concepts of equivalence relation, Cauchy sequence, and metric space. The thesis that is disused. The thesis is that disused definitions of these notions could profitably be revived. Okay. Authors accepted manuscript accepted 3rd March 2026 after peer review for publication in Mathematical Intelligencer. It is not the version of record and does not reflect post-acceptance improvements. I need a volunteer to help perform a magic trick. Are you game? Your task is to propose a certain mathematical question to a third party and to record the answer without letting me see. If you are a student, you might text the question to a classmate. If you're an instructor, you might poll a class or consult a colleague. Alternatively, you may query your favorite artificial intelligence assistant. Boo! The question is based on the background of your interlocutor. For a beginner just learning how to write proofs, the question is to specify the defining properties of an equivalence relation. For someone familiar with rigorous calculus, the question is to define the concept of a Cauchy sequence of real numbers. If your informant has studied the elements of point set topology, the question is to state the axioms for a metric space. After obtaining an answer, read on for my divination of what you were told. Imagine that I have made a magic incantation ending in Eureka. If you ask the first question, the response you got was an equivalence relation satisfies the following three properties, implicitly universally quantified: reflexivity, symmetry, and transitivity. Right, or commutativity asterisk. If you ask the second question, the reply was that a sequence of real numbers is a Cauchy sequence when for all epsilon greater than 0, there exists an n for all m greater than or equal to n, for all n greater than or equal to n, such that the absolute value of x sub m minus x sub n is less than epsilon. The answer to the third question was that a metric space means a set E together with non-negative function D on E cross E, satisfying the following three properties, again implicitly universally quantified. D of xy equals 0 if and only if x equals y, coincidence axiom. D of xy equals D of yx, symmetry axiom. And D of xz is less than or equal to D of xy plus D of yz, triangle inequality. Did my mind-reading trick succeed? I believe so. The magic here was solely in the selection of the questions. If the topics had been instead a function, real number, and vector space, then I could not have confidently predicted the response. The three concepts that I chose, however, were codified in textbooks long ago, and modern students all learn the same definitions in substantially the same conventional form. The statements are a part of mathematical culture, like the legend of Archimedes in the bath. Speaking of Eureka. The tale of Archimedes contains a grain of truth, but is apocryphal. Yes, yes. As is Pythagoras and the beans, by the way. My startling assertion is that, analogously, these three standard textbook definitions are plausible, but also wrong. To be sure, I am not suggesting that these definitions are unsound. What I mean is that the right definitions are shorter, simpler, and more insightful. In audaciously challenging the conventional wisdom. I am being playfully provocative in the spirit of pi is wrong. My initial goal in this article is to formulate. A quarter century ago, Bob Palais promoted in this journal the opinion that the right circle constant is the ratio of the circumference of the radius, namely 2 pi rather than pi. Rather than circumference to diameter. Yeah. My initial goal in this article is to formulate and popularize some appealing alternatives to prevailing definitions of the three concepts dating back a century or more. These formulations, curiously, have dropped out of the everyday toolbox of mathematical workers. My second objective is to trace the history in sufficient detail to name the creators. Today's standard statements seemingly arose as much by chance as by choice, and I tried to identify the historical turning points when the variant definitions slipped through the fingers of fame and fell into footnotes. My third aim is to light candles in remembrance of scholars whose names, like their definitions, are fading from collective consciousness. Both for obscure figures and for revered icons, I offer glimpses into their lives to enhance the appreciation of their achievements. For example, Augustus de Morgan had a recipe for the algebra of sets, which is more piquant when seasoned with the awareness that, as a boy blind to one eye, de Morgan overcame bullying at school. All things being equal. Did the ancient Greeks anticipate the idea of equivalence relation? If Euclid is accepted as a representative of classical mathematics, then the evidence is ambiguous but tantalizing. The first common notion in Euclid's Elements states, things which are equal to the same thing are also equal to one another. Although Euclid never defines equality, the import evidently is more general than simple identity. If equal is interpreted as equivalent, then Euclid's first common notion becomes the property used to prove that two equivalence classes must either be identical or disjoint. The Elements calls congruent line segments equal. Robin Hartshorne observes there are no lengths in Euclid's geometry, so we may regard equality to be an equivalence relation on line segments. Book 1 of Elements culminates in the Pythagorean theorem, which states that the square on the hypotenuse of a right triangle is equal to the squares on the other two sides. Euclid's meaning is formally stronger than equality of areas, for Euclid calls rectilinear figures equal if they can be converted into congruent figures through the operation of removing or adding congruent triangles, iterated finitely many times. This notion of equality is an equivalence relation. Book 5 of the Elements, presumed to be based on the work of Eudoxus of Cnidus, defines ratios a to b and c to d of abstract quantities to be the same for when arbitrary natural numbers m and n form the inequality ma greater than nb holds if and only if mc is greater than nd. And similarly, ma is less than nb if and only if mc is less than nd. Does the device of declaring distinct objects to be the same ring a bell? In the words of Christopher Zeeman, Eudoxus and Euclid must have been thinking of a ratio as something like an equivalence class. Thus, Euclid knew some particular examples of mathematical structures that now are understood as equivalence relations. According to the principle of indeterminacy of translation, W.V.O. Quine, there is no way to know how the ancients themselves conceptualized these examples. I doubt that Euclid had any notion of abstract equivalence relations in general, for the relation concept did not get formalized by mathematicians for another 2 millennia. Adrien Marie Legendre published a textbook in 1794 intended to make Euclid's geometry more accessible to students of the time. Legendre's influential book went through many editions through his lifetime and multiple translations and posthumous revisions by various editors. Yet Lewis Carroll maintained, based on extensive teaching experience, that the book was suitable for advanced students only, not for beginners. Harold Dodgson, by the way. reserving the word equal for planar figures that are congruent. He can introduce the word equivalent for figures that have equal areas. During the ensuing 19th century, the concept of an equivalence class was in the air, so to speak. Hey Famish, how's it going? Nimdoc, good evening and welcome. Psychologist here for science streams. Excellent. We love a bit of Friends of TKF here. That's not really what I wanted, but we have our gaming and math content channels listed here at Obi-Wan Pez for gaming and at Nsimflex Pachinko 6542 for our math content. And here we have all of our math friends who are, this is not even all of them, but these are many of our math friends. Academy of Useless Ideas, Dr. Gold from Actual Education, Don Factorial, E.N. Stuckey, Zach from E to the 2i Pi, Meriwether Remark, Phobos Dream, Penn Center, Physics and Depression, Talos Teaches, and the Tutor Wizard, as well as our study buddies, Rendeo, Math Spellbook, Fizzbuzz, Suna Ao, Walking Stick Library, and Damie, who have all been instrumental in expanding our, gigantic sphere of mathematical influence. So, your parents are software engineers, family mathematicians. Nice, nice. Infoset, welcome. Thank you for the follow. Be sure to tell your friends. So, we've been doing a bunch of Math Communication Mondays. We have also been doing calculations on Wednesdays, and on Tuesdays we've been doing kind of pickup games, whatever we've got. At the moment we're doing blueprints, which is quite possibly going to take us till the end of time to actually figure out. Once we get all of the red envelopes, I may end up stopping. On Thursday we do D&D prep, which is not technically D&D, but whatever, it's fine. And Fridays we've been doing For the Long Game. So currently we're working on FF10. Well, maybe. We're currently working on Baldur's Gate 3, as well as hopping back and forth in Elite Dangerous. Currently, we're finishing up the Distant Worlds 3 expedition, which was a deep space exploration mission, like into the dark end of the galaxy and back. So there's a place called Beagle Point, which is on the literal opposite end of the Milky Way galaxy inside of the game. It's not real because you can't see that far in the real Milky Way. But our expedition made it all the way up. We're on the way back, almost back to home. We've got another 2 weeks or so before we actually, just under 2 weeks before we make it back to the bubble, which is Sol and all of the systems which are within a couple hundred light years. I was working as a member of the science expedition, so we were going out and doing a stellar density survey of the Milky Way galaxy as rendered in the game. So we're trying to figure out, we're trying to figure out the algorithm that was used to determine the stellar density across each of the stellar arm bands, as well as in the black space between, as well as all these other things. So we're doing all sorts of cool stuff. Your great uncle is culpable in the creation of AI expert systems. I also took a class on neural networks for my master's, which was very interesting. My spouse and I both took it. She from the perspective of computer science major, and I from the perspective of applied math. So we've had some interesting discussions between the two of us. And this book right here, Peter F. Hamilton's Salvation, was an interesting look into using AI agents. So, like, pretty much everybody in that book has agents, and they're all doing agenty type things. You know how it's going to go, I'm sure. It's very interesting. Venn diagram of science and scientists and gamers. Yep. Yep. And again, TK. Human social cognition. Yeah. I'm a big fan of Robert Miles, who is an AI safety researcher and has been tapped by the UK government to be on, if not head, a AI safety research consortium. So like he's part of a fairly large circle of AI safety researchers in the UK. He also has a YouTube channel which is very interesting, and you can watch all of his stuff. It's brilliant. Yeah, I love his stuff. He is amusing, self-deprecating, and also very informative. And you can tell, like, he knows what he's talking about. It's not just some YouTuber yapping away, like, this guy. You get me talking about actual mathematics that I understand, like the stuff that I've taught for 15 years, and I can keep up with pretty much anybody. But if I'm just riffing, like Scott Barry Kaufman, interesting. You ran out of coffee? No. I'd give you what's left of this, but it's a long way to shout. Well, Nimdoc, nice to meet you. And again, I recommend all of those people, whatever direction you have this all in. I still have some of the blueberry, yeah. Seltzer and your kids' leftover snacks. Those can be really good, but at the same time. Nimdoc, do you know TKF as a group? I don't think I have. No, I don't. Never mind. Okay. The Knowledge Fellowship. Yep, there we go. And click. Now, I will admit that this is not a particularly active channel, but the Knowledge Fellowship does tend to link to all of the other people. So the Knowledge Fellowship is run by like a couple of people, and then there's a board that's under them of like, I don't know, 20 or something like that, who all discuss the content of the creators that are on the platform, so on Twitch specifically. And they have actively recruited other people within the EduTwitch community. So Zach, E to the 2I Pi, is a member, like an official member of the Knowledge Fellowship group. So like the stream team. And there's a number of other people who have applied for it. But they're really awesome people, just as a whole. And they all, whenever they can, they all link to each other and try to get people more involved in learning stuff on Twitch. So if you're interested in learning stuff on Twitch, they're a great resource for it too. And yeah. You have been drinking soda lately. So bad. Yeah, well. Yeah. Ask the shrink, learn from shrinks. I mean, definitely. If you are interested in doing educational things on Twitch, I would contact people through TKF and be like, hey, who does, psychology? You know what? Hang on. If I can quickly find TKF, here we go. Social science. Mr. Aegis is one of the people who usually is running the TKF channel. Yeah. So if you actually go on to the TKF, yeah. Yeah. Mr. Aegis posted on 30th of March. Would still love to do a collab with perhaps a psych-related streamer on the effects of pornography. Related. If anybody knows Valenvane, he's got educational psych. Oh, nice. Well, I know that Zach and I would love to talk with you about all sorts of cool stuff, because I had done. I mean, I took educational psychology, but that was like 25 years ago, so things are different now. Yeah. Awesome. Cool. We're allowing that. That's yeah. Automod is always very overzealous. Automod hates my name. Yep, you get the backseat. Yep, definitely. There is a subset of letters in my name which is a slur. Valenvane is a sex education streamer. So not completely relevant to our conversation, but relevant to the random thing that I found about Mr. Aegis wanting to do a discussion about, well, pornography in general, but, you know, sex education would fall into it. Anyway. Yeah, my favorite was when I got into somebody's stream and followed them. It popped up with a thing that said, that. It had an autocomplete, basically automod, like removes the offending thing and throws up a random sparkly word. I was like, oh god. let's not call attention to it. Yep. Actually, I think that might have been Rocket Sage, who's geologist and one of the leaders of TKF. So she's on the board. But it was the same sort of thing. I was just like, yo, okay. we're just gonna call it right out. Okay. Yeah, I'll tell you though, I actually had 3 of the people in like our math group coming in as viewers to my channel, and I had no idea that any of them were teachers. They were just chatting and stuff, and I was just like, yeah, it eventually came up that all 3 of them were teachers, and I was like, hang on. So I clicked into their profile, and it's like, was last live 2 days ago. I'm like, okay. So it was a Penn Center, Zach, and probably Danny, who's not really around much anymore, but that's all right. And then like Ian Stuckey, Don Factorial, they all started coming in. We all started hanging out around each other's channels all the time. So it's been working out really well. All right. Minute 45 to discuss that? Yeah, probably. So my spouse had been working in Maryland, and I was working in Maryland as a teacher at a community college. And one of her direct report boss moved out to the UK for 3 years to do a tour, and she got her own department. So, if you're looking for your own department, right, and you're an assistant, then you get to be the manager. Like, that's pretty awesome. So she moved out to the UK, got her own department, and then was like, hey, so you want to move out here? And the spouse is like, yeah, okay. I'm gonna uproot my entire life, uproot my husband's life from doing all this stuff. Yeah. And then like 3 weeks later, she sends another text. Is like, no, you want to apply for this. And she finally looked at it, and like the financial packages and all this other stuff were kind of like, okay, so even if you don't work, we'd still be better off. Because our housing is all paid for, and the kids' school is all paid for, and, all this other stuff. So we're seeing how we're already 2 years in. We've got 1 more year and a few months before we move back to Maryland, and we'll see how things go. I'll see you all in 3 minutes. We got ads, so yeah, get up and stretch and do all that stuff. If anybody's leaving, see you later. If anybody's interested, the GOtEL Game On to End Lupus link is down there. That is our charity this month. And otherwise, yeah, see you in 3. All right, welcome back. All right, so I don't really have room, unfortunately, for staff warm-ups, but we will work on some of the Tai Chi warm-ups that I do on a regular basis. I take Tai Chi classes from this guy in Yorkshire, in England. We do he's been so awesome. We do what is essentially a solo class on Wednesdays, which by itself should be costing me like, I don't know, at least £100 a month. The guy's awesome. And then also doing group classes on Saturdays. And so we've been just doing those two twice a week, every month for 55 pounds. I'm like, I am robbing you. He's just like, I mean, nobody's showing up. It's not your fault. So the basic idea behind this is we're sort of just letting the arms go almost limp and just kind of directing their motion rather than specifically like whipping them around. So try not to do anything with your arms except just make sure they don't hit things. Because I am getting kind of close to the wall here, but and basically we're trying to turn at the hips in order to cause our arms to whip through. So rather than doing any actual any actual hitting or any actual whipping hard with the hands, we're just getting kind of used to the hip rotation and trying to get it so that as you tuck into what's called the inguinal crease, it's that bit right in the groin, where when you turn at the hip, you can feel like the crease between your thigh and your abdomen in that particular spot. There's a whole bunch of fascia, so the fleshy bits that are like not muscle, but the fibrous tissue that's in there, which help to essentially store energy. It's not energy in any sort of woo-woo sort of way, but people have done biomechanical studies about this stuff, and a lot of the traditional Tai Chi, Kung Fu, martial arts systems tend to use Qi as something they don't understand and a mystical force and all this stuff, but realistically they're just they're training their bodies to store energy into the fascia and into the muscles and into other bits in your body. So we do that one, right? So we just twist at the hips, you can also tuck into the inguinal crease as you go and step into it, and it gives it a little bit more power. You got to be careful though, because I tend to whip really hard with my hands, and it increases the blood pressure in my fingers way too far. So I can get a little tingly if I'm not careful. Next one is we just do the same thing, but up the front. So we just kind of let the arms fall, and then just bend the knees a little bit while standing at the fronts of your the balls of your feet. You want to not take your heels off the ground, but most of the weight should be on the balls of the feet or just behind it. There's a nice little place. I can't do this, but there's a nice little place down here, just behind the balls of the feet, which again kind of helps make sure that when your weight is centered there, it does some beneficial things. Again, just kind of duck the knees just a little bit and don't do much with your arms apart from just letting them fly, right? It's just like a kid on a swing, right? So move your weight a little bit until the arms go flying. And then let's see, what else do we do? We could put one foot forward, one foot back, and do the same thing forward and backward on the balls of the toes or balls of the feet. So again, same deal. Just kind of move backward and forward. Don't let the arms flop and then, yeah, keep doing all this. It's all good. And then eventually switch. Foot mat with faux zones, nice. And then we've also got some silly ones, which my instructor said do not do these every day, because the guy who developed them used to do these sorts of things every single day for the first like hour of his day. And he was living in Malaysia at the time and doing a lot of martial arts training and helping people become better martial artists. Like, he was doing that for a living. So every single day of his life, he would get up in the morning, he'd take a shower, he'd do an hour of these things, and then be soaking wet, so he'd have to dunk himself again. But take your hands and you just sort of like move forward and snap them like this. And then you can also let them fly on the way back, and it helps with the flexibility in the wrists. The problem with this is that if you do all of these exercises, and there's like 20 of them, if you do all of them every single day, you essentially just age your joints. And so like the guy, doing them once a week, twice a week, not too bad. Doing them every single day or multiple times a day wrecked this guy. So he used to be super fit and agile and all this stuff, and now his joints are all just like terribly inflamed and he can't do anything. The next one is very silly. We go out and then back in. This one's called the baby bird, I think. The exchange rate. Oh, goodness, that's a good question. Last I checked, it was 5 to 4. So like the dollar and the pound were actually pretty close, but they're not so much anymore. There's like 50 more, but the other one that we did was there's a whole bunch of stretching that we do at the end of class that are super important, that if you do them, self-regulation, it is bonkers. Like what do we do? So most of the time we go kind of back like this, stretch, come down all the way, squat, and then bend back from a squatting position, stand up, come back down like this. And so if we do this a bunch, we usually do this at the beginning of class, but it seems like it could also work pretty well at the end as well. And then usually we, bend down, touch the floor. When you're standing up, you have to like pick your head up, let the blood drain for a second, and then stand all the way. There's one we do. There's a good one. So you put your hands kind of against the bottom of the belly here, and then you breathe in and then out this way, and when you actually like push your arms down gently. Breathe in, and then when you breathe out the second time, you bend over and touch the floor. And most of the time, when I do this the first time, I can only get essentially like this, or maybe touch my that part right there on the top of my palm. Like I can touch that to the floor, but that's about as far as I can go. And then what you do is you do it, again, And this time, I'm actually touching my entire hand to the ground. And if you do it multiple times, you can press harder and get further and further down to the ground. My spouse does not have have trouble with this because she has very short legs. She's like, "What are you talking about?" I'm like, flat palming the ground already. I'm like, man. But one of the lessons that we learn in Tai Chi is that this particular thing, the touching only to like here, and then touching to here, and then touching to here, as we're all the way up, is really a factor of the relaxation of your mind, because your body can do that anyway. Your body is, generally speaking, way more flexible than your brain allows it to be, because you're essentially trying to prevent your own damage. You're trying to prevent your own injury. But, as long as you're doing something in a safe and controlled manner, generally speaking, you're not going to hurt yourself. You have to be a little careful sometimes, but with something, a stretch like that, getting yourself into a relaxed mindset ends up being more important than, allegedly getting your body to relax. Or, in theory, you're getting your mind and your body in sync with each other in the relaxed state so that your mind doesn't tighten something up and say, no, don't go that far. One of the other things that he said was that a lot of the masters in Malaysia will say that particular set of exercises is forbidden to teach people. It's secret, all this other stuff. And he was like, you know why they say that? And he's like, a lot of the really tough guys will be like, I don't want to do yoga. Like, I didn't sign up for yoga. I signed up to do Tai Chi and practice my body and practice my mind and all this other stuff. But by just saying that it's forbidden to teach this, it's a secret thing that your instructor is giving you. I don't remember what a crow pose is. But anyway, a lot of those guys, a lot of the tough guys will be like, nah, I don't want to do yoga or whatever. I signed up to hit people. And so principally you worked for banned yoga because yeah. Oh, nice. I used to be able to do that. Yeah, the problem is that I just weigh close to 90 kilos. So I could probably pull it off, but I don't. I know some pregnant women who were able to pull off something very similar to crow pose, if not that one exactly. But yeah, especially if it's throwing off your balance and Oh man. doing that. I don't know how I feel about that, because that's working your pelvic floor. And like, good honor, I suppose, for like getting that strengthened up, but at the same time, like, I would be kind of worried that that might put you into early labor. Yeah, yeah. Yep, same mind. And maybe that is just an old wives' tale and could never happen, but at the same time, if eating spicy food can put some women into labor, you'd think that, oh, and physical exercise generally is also one of those things that people encourage when it's like, oh no, this baby's coming late. Like, they're like, do more exercise. But yeah, that's a lot of abdominal. Oh. I didn't know I was pregnant. Oh, I have seen it a couple of times, but yeah. That's interesting. It's interesting that question that you or the automated thing that you submitted, it blocked you on shit, but it didn't block you on fucked. And that's the second time that it did shit this tonight. Huh. Who'd have thunk? Oh, it was before. Okay. Yeah. Gotcha. Oh, last time it was in all caps. That's completely different. No, that's true. Yeah. However, as I'm looking at it, right, it says block terms found in message, and both of them are the same. So that's kind of interesting. But anyway, that's its own thing. All right, let's see. Let's get to the end of page 8 if we can. Maybe. Yeah, talk to the Automata engineers. I wish. Oh. All right. During the ensuing 19th century, concept of an equivalence class was in the air. The atmospheric disturbance produced multiple mathematical lightning strikes. First bolt was from the blue was from the publication of 1801 seminal treatise on number theory, which the young Carl Friedrich Gauss developed the basic example of congruence of integers. The thunderclap still reverberated half a century later in the ears of Augustin Louis Cauchy, who proposed an innovative definition of the complex numbers in terms of equivalence classes of polynomials, real without x squared plus 1, in modern notation. In 1871, Richard Dedekind introduced the equivalence relation on ideals of ring of integers of an algebraic number field initiated by the study of the ideal class group. In the same decade, Georg Cantor defined infinite cardinalities as equivalence classes under the relation of bijection. I also was listening to I don't remember which one it was. I think it might have been Breaking Math, the podcast, in which they had an expert come in and discuss the work of Georg Cantor, and specifically with relation to Richard Dedekind and the other guy. Very, very helpful. Specifically, Richard Dedekind, I think, was part of like the old boys group who really was upset about Cantor's notion that everything was kind of set theory, and all of this was going to relate to cardinalities and all this stuff. I think it was Dedekind was his detractor, but Dedekind really hated nope. Other way around. Dedekind and Cantor worked together and talked a bunch about a lot of the mathematics that was going on here. They liked each other's ideas. The issue was that Dedekind was hated by somebody else really big. Not Banach. Somebody else that big. Grr. Dirichlet, no. Hilbert, no. I'm getting closer. Not Ulam, come on. We're getting further away. Weierstrass. And Chronica. I think Chronica was the one who specifically just hated Dedekind and like absolutely worked against him in everything he did. And so this was the other thing, is that Cantor had to like essentially scrub Dedekind's name from a lot of the work that they did together, which is a big no-no in academia. But at the time, it was like, he thought that was the only way to get it by Chronica, and who was a referee in the journal. And in doing so, he really pissed off Dedekind. And so they stopped talking for a while. And then eventually, it was like 1872, they started writing to each other again, but Dedekind kept copies of all of his letters that he then sent to Cantor because he didn't trust him anymore. And then Cantor did something similar again, where he scrubbed Dedekind's name from something. And he was like, all right, screw this. I'm not talking to him anymore. Yeah, absolutely. Thanks for stopping in, Nimdok. And we'll catch you later. Yeah, and like I said, I'd love to talk sometime about Ed Psych and maybe work out like a, I don't know, co-stream or something like that. We'll talk. If you're interested. Yep, absolutely. Yeah, thank you so much. All right, we'll catch you next time. In 1871, I do not have a Discord, but we do. Sorry, we do use a community Discord amongst all of the mathy type people. But of course, it's like for anybody, for any reason. It doesn't have to be specifically math. Naturally. So I am Obi-Wan Pez there. And, yep, nice. Righto. We'll talk later. Thanks so much for coming. 1871, Richard Dedekind introduced equivalence relation on the ideas of rings of integers. We already talked about that. Cantor defined infinite cardinalities as equivalence classes under relation of bijection. Though these Prometheans revealed the secrets of specific equivalence relations, they left the formulation of general definition to mere mortals. Only in the second half of the 19th century did a theory of abstract binary relations gradually precipitate out of a fog of uncertainty surrounding the foundations of mathematical logic. In 1850, Augustus de Morgan highlighted the importance of the pair of properties that he called transitiveness and convertibility, now transitivity and symmetry. Relation satisfying these two special properties is an abstract cupola in his terminology. Charles Sanders Peirce used block diagonal matrices a quarter century later to describe copulatives. I'm going to leave that alone. Which are recognizable as being equivalence relations. Since Peirce was working in America, then a mathematical backwater. Yeah, well. Let's not go there either. His ideas were slow to influence the current of mathematical thought in Europe. Indeed, a calculus textbook of 1888 by Giuseppe Peano says that a symmetric and transitive relation is an equality, wording reminiscent of Euclid. When Peano formulated his axioms for the natural numbers, the following year he supplemented the definition of an equality with the assumption that every element is related to itself. Peano's disciple, Giovanni Velati, suggested naming this additional property reflexivity, a designation that was universally adopted. This reflexive, symmetric, transitive relation might well have ended up being called equality relations, for Peano's terminology was still circulating as late as 1929 when the philosopher Rudolf Carnap published his survey of symbolic logic. The neologisms equiparative relation due to Enrico de Amicis and isoid relation due to Philip E.B. Jourdain gained no traction. Helmut Hasse gets credit for the name Equivalence relation. In addition to making fundamental contributions in algebra and number theory, he succeeded his teacher, Kurt Hansel, as editor of the venerable GOtEL journal. Journal für die reine und angewandte Mathematik, a post in which Hasse served for half a century. Hasse standardized the following definition for the first volume of his treatise on algebra published 100 years ago. An equivalence relation is a relation that is reflexive, symmetric, and transitive. The most original thinker in an illustrious family, C.S. Peirce, should not be confused with relatives who held posts at Harvard. His elder brother James Mills Peirce was second Perkins Professor of Mathematics. These brothers' father was the renowned Benjamin Peirce, the first holder of the Perkins Chair and the eponym of present postdoctoral fellowships. The third cousin of the brothers was Benjamin Osgood Peirce, the seventh Hollis Professor of Mathematics and Natural Philosophy. Quine was Edgar Pierce Professor of Philosophy, but this unrelated Pierce is spelled differently. Hasse's definition sounds perfectly in tune, as to be expected from the hands of a skilled pianist. The three indicated properties are independent of each other, as Peano had discovered decades earlier, so the definition apparently forms a harmonious chord. Nonetheless, two discordant overtones can be detected. First, the character of reflexivity contrasts with the other properties. The reason that reflexivity failed to catch De Morgan's attention is, I imagine, that symmetry and transitivity are implications, but reflexivity is a mandate. Moreover, the following discussion shows that reflexivity is almost automatic in the presence of symmetry and transitivity. In the terminology introduced by Bertrand Russell, pictured recently in this journal in the stamp corner, at the turn of the 20th century, an element X belongs to the domain of a relation, tilde, on a set when there exists an element Y for which X tilde Y. If the relation tilde is symmetric, then also Y tilde X. When tilde additionally is transitive, the properties that X tilde Y and Y tilde X imply that X tilde X. This remark, which goes back to 19th century, yields the first variation on Hasse's definition. The essence of the following statement can be found as a proposition in Bourbacky's treatise on set theory. Russell's parallel term converse domain for the domain of the converse or inverse relation was promptly compressed by his follower Louis Couture to codomain, which is the more common term nowadays. An equivalence relation on a set is a symmetric and transitive relation whose domain is the whole set. The second dissonance in definition 1 arises because symmetry deals with pairs of elements and transitivity deals with triples. Each pair arises from some triple by setting two elements equal, so every property of pairs is a special case of some property of triples. Is there a natural property of triples that specializes to symmetry? Garrett Birkhoff gave an affirmative answer while studying the lattice of all equivalence relations. Transitive property can be represented by a directed graph as shown as figure 1. Property says that if two edges are present, then a third edge, shown dashed, appears. Right? Transitive, x to y, y to z, therefore x to z. Circular relation, x to y, y to z, therefore z to x. Birkhoff reversed the direction of the dashed edge, as shown as figure 2, to produce a property that he called circularity. This property of a relation tilde says that if x tilde y and y tilde z, then z tilde x. Birkhoff was presumably unaware that Velati had introduced circular relations under the name reversive some 4 decades earlier. Garrett Birkhoff, who held the George Putnam Professorship of Mathematics at Harvard, Garrett Birkhoff, should not be confused with his father, the mathematician George David Birkhoff, who was the 5th holder of the Perkins Chair. A reflexive and circular relation is automatically symmetric. Indeed, if x tilde y, then specializing circularity to the case that z equals y, and invoking reflexivity to say that y equals y yields that y equals x. In the presence of symmetry, the properties of transitivity and circularity are identical, so the following characterization is workable. An equivalence relation is a relation that is reflexive and circular. Works, right? The value of this definition is not solely the brevity obtained by reducing 3 hypotheses to 2. More significant is the demonstration that symmetry is a subsidiary property, not a crucial element of the definition of equivalence relation. The essence of the concept of equivalence lies elsewhere. Birkhoff apparently felt no compulsion to convert colleagues to his definition. The groundbreaking Survey of Modern Algebra, which he co-authored with Saunders MacLean, states Asse's definition of equivalence relation and relegates the notion of circularity to an exercise. I regret that I was too naive to ask Birkhoff about this circumstance when he was designated my faculty advisor during my first semester of college. Birkhoff and MacLean's later reminiscences, celebrating the 50th anniversary of their book, are silent about circularity, as MacLean's autobiography. Definition 3 does require reflexivity as a hypothesis. Indeed, the relation on the set XYZ, consisting of 3 ordered pairs XY, YZ, ZX, is circular, has domain equal to the underlying set, but is neither reflexive nor symmetric. The 2 questionable aspects of definition 1 can be addressed simultaneously by reversing a second arrow in the directed graph. The Euclidean property of a relation says that if x tilde y and z tilde y, then z tilde x. Since the letters are implicitly universally quantified, interchanging x and z shows that x tilde z as well. Reflexive and Euclidean relation is automatically symmetric. Replace z by y in figure 3. Therefore, definition 3 emits a parallel formulation which was known to De Amicis, whose adjective for Euclidean relationship was adequative. An equivalence relation is a relation that is reflexive and Euclidean. This statement is not the last word. Set z equal to x in figure 3 and see if tilde is a Euclidean relation, and x belongs to the domain of the relation, then x tilde x. In other words, a Euclidean relation is reflexive on its domain. This remark justifies ultimate variation on the definition. An equivalence relation on a set is a Euclidean relation whose domain is the whole set. Although this final definition is implicit in 1892 paper of De Amicis, the first explicit instance I know in the referee literature is a 1967 note by Charles Buck, who was active in mathematics education during the New Math era. He stated that the definition appeared in pedagogical materials for high school students in 1965. Taking definition 5 as a starting point, one obtains all of the standard properties of equivalence relations as a theorem. Theorem 1, an equivalence relation is reflexive, symmetric, transitive, and circular. George Eliot in 1850. Thus, Euclid's first common notion can be regarded as the fundamental property characterizing equivalence relations. This heuristic seems to have been folklore around 1870 before the concept of equivalence relation had a formal definition. Both the celebrated Dedekind and the unsung Charles Maurras chose to verify the Euclidean property of the relevant relation when justifying the existence of what are now called equivalence classes. Definition 5 has minimal hypotheses, but is the statement pedagogically effective? I think so, because students routinely encounter relations that are transitive without being equivalence relations. The inequality relation less than or equal to clearly is transitive but not Euclidean. The same is true for the subset relation, improper subset of. For the relation P implies Q in propositional logic, and for the relation K divides N in number theory. Such examples validate the assertion that the Euclidean property, not transitivity, is the decisive condition for testing whether a relation is an equivalence. Accordingly, the question arises of who first formulated Euclidean property for arbitrary binary relations. This significant event cannot predate 1850, for no general theory of relations existed before De Morgan's work. My candidate for the perspicacious pioneer is Marian Evans, who is a professional writer and amateur mathematician. In a discussion in the early 1850s with the prominent polymath Herbert Spencer, she formulated the axiom that things have a constant relation to the same thing have a constant relation to each other. Traces of the constant interest that Evans had in mathematics can be found in the acclaimed novels she began writing a few years later under the pen name George Eliot. Haha. Yeah, okay. We'll leave it here for next time. Alright, so there's the archive for this one for anybody who's interested. And we're going to head over to Damie's channel. Damie VTuber is currently working on making exercises for the intro. I'm not sure entirely what they are working on at the moment, but ought to be cool. So we're going to head over there. I hope you all are having a good week, and we will see you potentially tomorrow for some blueprints, Wednesday for some calculation type stuff, Thursday for some TTRPG prep, and Friday for some more games. So we shall see you later. Hope you all have a good night. My name's Obi-Wan Pez. This is N-Simplex Pachenko. And thank you so much, everybody, for coming. You do have the QR code down there. And you can check the VOD if you're interested in donating to GOtEL, Game On, to end lupus. Jeez, I'll get it one of these days. And thank you so much to 8BitD, Elbel, Coco Confession, and all the other great